Hi, everyone. Thank you for joining us today at BEL for our webinar on flow. This is part of a series of workshops we're doing on the BEL suite of products, and you can find the other workshops on our website, such as the Sorcerer webinar and the BEL EEG System 1 webinar. My name is Corin Tucker. I'm the marketing director at BEL. And we will be introducing Flow, which is our EEG ERP database and workflow manager. I will also be the moderator today for our webinar. And I will ask you to put any questions you have into the chat that we will get to at the end of our webinar, and we will answer questions in our Q&A session. We have several speakers today for the webinar. The first is Wei He, the Director of International Sales and Strategy. And just to highlight the collaborative nature of Flow, Wei is in his Eugene office. Ian Brown, our lead software engineer, is in Portland. Evan Hathaway, our scientific software engineer, is in Portland. And Justin Nichols, sales manager, is in Dallas, Texas, and will join us as well. So I will go ahead and hand it over to Wei He to introduce Flow.
All right. Hi, everyone. So let me share my screen here and also activate my video camera so that people can see me. Hi, everyone. This is Wei, and really glad to be here to share with you our new products, Flow. So can everyone see my screen? Yes. Flow stands for forward-looking operation workflows, and it's BEL's informatic platform for BEL users, data processing and review, data storage, and data management. And it interacts with other BEL products, such as the BEL AMP. Once the EEG that's being recorded from the BEL AMP, the data will be automatically pushed into the Flow server, this platform for data processing and data review. And the admin of the Flow can manage the data access from the different collaborators. Flow also offers license management. When you purchase a Flow, it will automatically come up to 10 seats of license for allow people to simultaneously access the Flow for data review and processing. Also, Flow offers a Jupyter Notebook access for more sophisticated data processing in today's research world. Open source softwares that's available that really give people a larger horizon to process more sophisticated, in-depth data process analysis. And the MNE Python is one of the powerful tools that you can actually directly from Flow to access the notebook for MNE Python data processing and handling. So the Flow come with a on-premises a server as our first release. So you will receive a GPU come with the software, and it will sit in your lab and allow people to access this server remotely for data processing. We also, in the next release, will offer the AWS-based cloud service. And this is what we were using also mainly in our company, we're using AWS. But we offer these two options. The AWS is the Amazon cloud service. And it's with that, it's powerful cloud-based that you basically can access from anywhere in the world to that service. We offer these two options is because some sites may actually, for example, hospitals may not allow to use the AWS. So a server will be a more, protected and have the total ownership of that data of itself. So flow is the structure is you have on-premise CPU and client to access the flow. Basically, you just have any computer that have a Google Chrome browser installed. You can open that browser, typing the flow address and log in. And the flow interface, here's the flow interface. We see basically four steps in the flow to actually get to implement data and process the data. You open the interface. It's really easy to understand. We designed flow interface in a very easy to handle and user-friendly. And to access the data, you just find the data file and click the workflow button, and it gives you different workflow options. Sourcer is our source localization software. Bellevue is our in-house EEG review software. And these are all web-based browser, web-based, web page-based. And you also have the ERP workflow. So Sourcer and ERP Bellevue, these workflows are available in Flow. For more advanced data processing, you can actually go to the notebooks and for more in-depth data processing. After finish, if your code in the notebooks also generate output file, a processed data file, for example, it will also can easily write back into the Flow database. So this whole process make this workflow a seamless and integrated workflow. So Flow itself as a server allow multiple access. So people from different locations, whether you're in the lab or outside the lab or anywhere, and you can actually remotely access the flow with the computer you have and for various data processing. So next, I would like to do just a quick demo of the flow platform. So let me do so open a Google Chrome, type in the address of the Flow server, and this is the front page, and type in the credentials and log in the Flow server. On the left is the Flow menus. Start with the experiments. So the Flow data organization is based on the experiments. Experiment is a data folder that is store all the related data files related to this experiment. And you also have the active workflow that will show if you run a certain workflow, a process will list in the active workflow list. And workflow history shows all the logs of the history logs of the flow, the workflows that's been running, the people are running, and types, participant, username, who owns it, and the status. User is who has access to this flow, and this is managed by the admin, the lab manager, and later Evan will give you more details about the license management and data safety. Notebooks allow you to actually access the Jupyter notebooks and to do the Python coding. Here we are running on AWS. So, but for the first release, the customer will receive a GPU that comes with 1 TB hard drive capacity for data management. So let me go back to the experiment and find a file. So under the experiment, you can see on the left, there are 4 different icons. From the left is the show file. So if you want to allocate a file, click this button and allocate a designated file. And show participants shows the subject information, the subject where this data was collected from. And the third one is the show collaborator, who has the access to this particular project. And this is all manageable by the lab manager. And you can also edit the information about this experiment. So let me find the N170 workflow demo that we're going to use as a sample. So click on this file, and you can see there is two different participants. I like to use this one. Okay. And this is the data file called ERP sample 002. You can click this icon, the download icon, to download this file to your local drive. And the view info shows the information about this file. Right now, this is a raw file. It's not being processed. But if you process this file, the histories of the processes of this file, the settings in regarding to processing this file, so will all being recorded and show in the view file info. So let me do just to do a quick ERP demonstration. So here, this file, the BEL view, I open the BEL view, and this is a raw file. You can see a lot of eye blinks in the beginning, and this is a data collect based on using the N170 paradigm, typical face recognition paradigm. The vertical yellow line you see here are the the events, the TTL markers that sent from the experiment control interface. And on the top here, you have the annotation track that shows all the event information here. And on the left, you have all these typical settings for showing tools for, set for different purposes. Under the view, you have how many channels you want to view in one page. You can choose that. Scrolling steps. Now remember, we have our system are up to 280 channels. That's a lot of channels. So we allow the user to actually choose the speed of the scrolling by choose these scrolling steps. And there is also annotation, hide annotation marks and hide channels. These can be handy tools for you to use when you review a data. Montage here allow, we have, besides the native montage, we have 1020 and double banana typical montage that people use. The viewer filters, these are typical notch, low pass, high pass filters. Impedance shows the impedance records of this data when the data is being recorded. Amplitude scale, time scale, really when you can choose the relative to right amplitude scales and time scale for desired viewing proportion for optimized view of data. So let me close this one and just run the data. Click ERP, and we have this standard ERP working process that includes the filtering, segmentation, artifact detection, averaging, re-referencing. And this is to showcase that the flow has this containerization and scripting feature that allow to really package any tools that that we want to add into the flow. So let me click this run button to run the file. Now, once I click run, you can see there is activities in the active workflow. And it's pretty quick. You see that it's already done. It's been finished, and new file is generated called average N170. So let's see the result. Choose the workflow and click BEL view. Now what you see here is two types, face and left is the face, and right is the left is a character, right is a face stimulus data. So let me set to the desired time scale and amplitude scale for more clear view. Now, what you see here is the typical N170, especially in the occipital region here. These are the typical N170. These are the face versus a character. You see the face have a more clear, bold, and larger negativity, deflection negativity from at the N170 at 170 milliseconds time point. So this is just a very quick demonstration of what you can do with the flow. And I will turn the table to Ian, the lead of our software department, and he will introduce the data management and license management and data safety part of the flow, which is quite important for many customers also.
Yeah, let me share my screen real quick. Okay. Yeah, as I mentioned, I was going to talk about license management and data protection within Flow. So starting with licenses, the main two types of licenses right now are Flow and Sorcerer licenses. So the Flow license is kind of allows users to do pretty much the basic functionality within Flow, all of the things that Wei just demonstrated now, you know, downloading data, uploading data, launching workflows that go in the background, that kind of thing. And then there's Sorcerer licenses, which are another product that can be launched from Flow. And the Sorcerer license allows using that other product. And there might be additional license types that we add on later, but these are kind of the main ones right now. So the way that we keep track of these licenses for different customers is that BEL has a license server that we maintain, and as new customers are added, we add customers there, and as licenses are purchased for those customers, we'll add those there. And then each individual Flow server communicates with that license server. So it'll periodically synchronize with it to essentially fetch all of the licenses that are available for the customer that the instance is associated with. So it will take all those licenses and kind of maintain a copy on the individual Flow server. And then that's just done so that if for some reason the license server can't be reached because of internet connection issues or anything else, you can continue to use it while it wasn't able to connect to it. So that just allows using that most recently synchronized point of licenses and still using it without any interruptions. So then over here on the right is just a kind of a simple diagram of what these license acquisition might look like. So the process of acquiring license happens completely automatically. Whenever you log into Flow, it'll automatically try and fetch a free license for Flow if one's available. And if one's available, you'll just proceed to log in and use Flow normally. And if not, you'll just be prompted that there aren't any free licenses currently. And then same thing for Sorcerer. Whenever you launch Sorcerer from Flow, it'll just try and acquire a Sorcerer license automatically and just proceed to using Sorcerer. And then similarly, whenever you're done using Flow or Sorcerer and you've closed all of those tabs that are using it in your browser, it'll automatically release that license and just make it free for another user to start using. So then now I'll talk a little bit about access control within Flow. So Flow uses what's called a role-based authentication scheme, where each user type has a role assigned to it. So currently there's 3 roles within Flow. There's an admin role, which is the most privileged user type right now, and that involves pretty much anything the other roles can do, as well as some specific things for managing the Flow instance. For example, like viewing the available licenses and things like that. That's something that admin users are able to do. There's a lab manager role, which is still able to create new experiments and create new researcher users. And then there's the researcher role, which has the least amount of access. They aren't able to view other experiments by default. They need to be added as collaborators to experiments by the experiment owners. So this is just done to give the owners of experiments a bit more control about who has access to the data. And then similarly, adding collaborators, you can remove collaborators later on if needed. So there's another feature in Flow I wanted to just touch on briefly for carrying out maintenance of the instance or software updates. We have this remote access feature. And essentially what this does is an admin user can turn this on or off. And what this will do is open up a temporary access for the BEL support team to be able to do anything it needs to do on that Flow instance. So this is, again, controlled entirely by the admin, and usually how this will work is we'll set up a time for maintenance or software updates, and the admin will turn this remote access on. And then when we're all done making any of those changes, they'll just turn it off afterwards. And this is, again, just to give the users of the Flow instance complete control over when and how this remote access happens. And then there's just a few extra points I wanted to talk about in general security for the Flow instance. So the instance runs on a local private network. What will happen is this instance gets shipped out to the customer, and then they'll install it and set it up on their local network, which means that the only way to access it is by either using that same local network or using a VPN, but it won't be publicly accessible, which is good for data security and managing access. So each instance also comes pre-installed with a firewall. This will block essentially all traffic that isn't needed to interface with Flow. So it's just another security measure we're taking to make sure that that there's not any unnecessary traffic there. And then Flow also uses HTTPS using TLS. This will encrypt all the traffic going to and from Flow. So whenever you open up a browser to use your local Flow instance, you'll be downloading data and uploading data, and any other interactions there are going from your browser on your system to the Flow server. And just taking this extra step to have HTTPS set up, make sure that all that traffic's being encrypted, so there aren't any possibilities for leaking that data or anything over the network. And then finally, this remote access feature that I talked about, we use public key authentication to manage this. It's just another measure we're taking to make sure that the people using this remote access is guaranteed to be BEL support. And it also, again, encrypts all of that traffic over the remote access connection. So, and then real quick, I'll do a quick demo that just kind of goes over some of these topics I talked about. So here I have a Flow instance and a login as an admin user. So as an admin user, I'm able to view the current licenses on a Flow instance. So if I pull up this licenses view here, here I can see the licenses of each type and how many are currently in use. And then here you can see, these are Flow licenses. They're in use by a few different people. And then there's other licenses that are free at the moment. So for example, if I go to an experiment and I open Sorcerer, just in some file, and then I go back here to the licenses view, you can see now that that Sorcerer license has automatically been acquired by myself. And also this Flow license was acquired when I just initially logged in. And then if I close that window and refresh the page, see that that Sorcerer license was automatically released. So that's kind of what I talked about whenever you're done using either Flow or Sorcerer and you close your windows, those licenses are automatically released and made free again for any other users. There's also a feature as an admin where if necessary, you can manually revoke licenses if for some reason they absolutely need to be freed up in the short term. And what this will do is just, again, revoke the license manually, log the user out, and then free up that license. And then on experiments, we'll go over kind of the role-based stuff we talked about. So as an admin or a lab manager, I'd also have this ability. I can create a new experiment. So I'll create one here. And then that this experiment's created, I can add a participant. And then upload a file for that participant. Just do a drag and drop a file. So now I have an experiment created with one participant and one file. Like I mentioned, by default, none of the researcher users on the instance are able to view this experiment or any of the data, but I can add them manually by going to collaborators and then add new collaborators. And then from here, I can pull up any of the researcher users that are on the instance and manually add them to this experiment. So this way I can kind of control the access to the data. Now that those are added, they'll be able to see this experiment pop up if they go to their experiments view. And then similarly, I can remove collaborators just as easily, and it'll revoke that access to the experiment. Okay, I think that should finish up what I wanted to talk about. So Evan, if you want to go on to notebooks now.
Sure. Thanks, Ian. Yeah, my name is Evan. Hello, everyone. I've been with BEL for just about 4 years now, working on the science team and engineering team, and most recently the support team. And I will be presenting on the Jupyter Notebooks feature of Flow and do a little demo of that. Okay. Can everyone see my PowerPoint presentation?
Yep, we can see it.
Great. Yeah, so the Jupyter Notebooks feature of Flow, we added this to offer a way for users to create their own analysis scripts. And the nice thing about this feature is that it's highly customizable. So basically anything that you can do in Python, you can do, you can open up a Jupyter Notebook and do it right here, launch that directly from Flow. This gets rid of the hassle of having to set up your own coding environment. And for anyone who's done any Python coding or any other types of coding, that can take a lot of time, figuring out all the packages you need, making sure your package installer is there, and then there's always like a million things you need to install. But with the Jupyter Notebooks feature, it's pretty much just you go to Notebooks, you launch a new notebook, and everything's there for you. You can immediately start writing your Python code. So I find that really helpful. It also allows you to import data directly from the Flow database and then write data back to the Flow database. So that's really nice. So you're not having to make like a ton of copies of your data in different locations. You can work on it directly where it's sitting in the database. And I'll show how that works in the demo. It also allows you to have kind of this sectioned off workspace where you can create your scripts, you can store files there. Yeah, it's your own little Python workshop for analyzing data. So I'll demonstrate that as well. Before we go to the demo, I also just wanted to highlight, so like I said, anything that you can do in Python, you can do in a Jupyter Notebook in this feature. And they say that Python is the second best way to do everything, meaning that it's a very versatile coding language. So I just wanted to highlight a few different packages that you might find yourself using for EEG analysis. So one of them that I use a lot is called MFFPy, which is BEL's open source MFF reader and writer package. So this is really nice for just kind of dissecting MFFs, just parsing all the information, and then you can even write out an MFF. So say you want to step through some workflow and go from like a continuous file to a segmented file to an averaged file. MFFPy can be really useful for that. We could do, so there's statistics packages for Python so you could run all your stats in a notebook. Makes that really convenient. SciPy is a really nice library. Say you want to design a custom filter that you want to apply to your data. SciPy would be a really good library for that. We've got matplotlib for creating plots. So you can plot your EEG data, plot your joint time frequency plots, pretty much anything you can think of. And then MNE is the big one that we want to demo today. So this is a large package for analyzing MEG and EEG data. They've got readers for pretty much any EEG or MEG file type you can think of, which makes it really nice. You can read in the data and then use their preset workflows. And MNE pulls on uses actually 3 of these packages. They use MFFPy and SciPy and matplotlib. So, but it's all there, and they've got really good documentation explaining how to use their workflows and such. Okay, so let's hop to the demo. Is everyone seeing the my flow up here?
Yeah.
Okay, great. So here I'm on the Notebooks tab. This is what you'll see when you go to the Notebooks tab. So you can see we have a Workspace folder and a Sharespace folder here. So the Workspace folder, this is going to be your personal folder for storing scripts, storing files. And like I said, you should treat this like your analysis workshop, essentially. So you could use it to store maybe some intermediate files. Maybe you don't want to save every intermediate processing step back to Flow. You could store some of that here. You could store, maybe you have like a big spreadsheet of the subject information for all of the subjects you've used in a study. Maybe that would be a good place to keep it. And then you can pull from that in your scripts. But this is, yeah, just your own directory where you can organize it however you want. And this is going to be separate from the main Flow database that we would access through this Experiments tab. And then we also have a Sharespace folder, which any user of this Flow instance has access to this Sharespace folder. So that's really nice because you say you create your own script and you want to share it with your colleague who also is a Flow user on this account. You can share that script with them. You just drop it in the Sharespace folder and then they can access it, edit it. So it makes it really nice to be able to collaborate on the same script among multiple people. Yeah, so let's show how we can read data from the Flow database from within a Jupyter Notebook script. So first, I'm gonna jump to experiments here and then just show which file we're gonna be working with. So I'm gonna go to this N170 workflow demo experiment. I'm gonna do show files. this Zoom tab is kind of in the way, sorry. We have 2 participants here, so I'm going to expand this one participant. And we're going to be working with, it's a little covered up, but this last file. So it's just a continuous file that we recorded in our lab with 2 different stimulus types. And I'm going to show how we can create averages for those 2 stimulus types and then write it back to an averaged file and then save that file back to this participant. So if we go back to our notebooks, I'm going to go to Workspace and launch this notebook here. So here's what the notebook interface looks like. It's organized in what are called code cells. And each of these code cells can be run individually, which makes it really nice to see, you can have outputs from individual code cells instead of having to run the entire script from top to bottom. If we did want to run the entire script from top to bottom, we could go, there's an option for that. So I would go kernel, restart, and run all. That would run the whole script. So to run a cell, we're just going to click run. This first cell here is, we're just importing several packages. If you need to install a package that doesn't come pre-installed, you can simply do it with pip. You just put an exclamation point before the line to show that this should be run from the terminal. So that's what we're doing here. And then we can import MNE after we installed it. And then I'll just highlight this last import. So this is this API package is what we're going to use to interface with the Flow database itself. So this is something that comes pre-installed with the notebooks. So I'm going to run this cell. And then, okay, so let's load the data from the Flow database. So when I run this cell, this is going to give me a list of all of the files in this particular experiment that we're reading from. So if you'll remember when I showed you the experiments view, we were looking at this N170 workflow demo experiment. And here are all the files in that experiment. So there's 2 participants and then files for each one. So we want this particular file is what we're going to be working with. So we just got to plug in the information for that file right here. So we have the experiment ID, again, N170 workflow demo, the participant ID we get right here. And then the file ID, we do the index of the file that we want. So in this case, that is index 0 for this file. And then we're going to define the output path, which is just going to be the file name of the final output file, which is going to be an averaged file. So I'll run this cell, run the next one. Okay, and so now that we have the file, we have our data file object, we can go ahead and read that raw data with MNE. And I just want to highlight that MNE has lots of reader functions for different file types. So here I'm just jumping to their documentation. So they have pretty much any EEG or MEG file type you can think of, they have a reader for it. So like Brain Vision, we've got EDF, BDF, GDF, Neuroscan. And yeah, I would also encourage if you ever have any questions about MNE or like what it's capable of and such, their documentation's great. You can just keyword search anything you might want. So you could like look up filters, and we can see background information on filtering. So they've got a lot here. Okay, so back to the script. We're going to go ahead and read this file with the MFF reader function. And then we can apply a bandpass filter. So here we're applying a filter from 0.1 hertz to 30 hertz. And then we get, this is really nice. It'll print out all the filter parameters for you. We can do some marking of bad channels and also show a chart view of the EEG data. And Jupyter Notebooks has this really nice feature for interactive plots. So this plot, believe it or not, is scrollable. So we can jump around in time here. And yeah, so we're just viewing the chart view for all the channels in this data, which there are 130 channels in this particular file. So we can scroll through the channels and look around here. So yeah, we can see that channel 6 is not looking so hot, looks pretty flatlined. So let's mark it bad. And to do that, so I've already done that here, but we would just set this raw.info bads property to a list of the bad channels. So here it's just a list with one item that is channel 6. And then if we run this and then we plot the chart view again, we see that channel 6 shows up in red, indicating that it's bad. Okay, and then we can go ahead and interpolate that channel using the data from the channels around it. And then we'll plot the chart view one last time just to demonstrate that now channel 6 has been interpolated. So we can trust the data from that now. Okay. We can do some segmentation around different event types. So here we're segmenting around the 2 different stimulus types in this experiment. So in one condition, the participants saw a written character, and in the other condition, they saw a picture of a face, and we're gonna create segments around those 2 stimulus types. So we'll run this. And then we can do a little bit of artifact detection to drop bad segments. So here we're just dropping bad segments that exceed a 200 microvolt peak-to-peak amplitude difference. So we'll see what we get there. So we get a readout of all the different segments that were dropped, and it shows you the offending channels. And then at the end here, we can see 63 bad epics dropped. And then we still have 126 epics for the character condition and 131 for the face condition. Okay, so then we can take those segments that we created and average them by event type. Oh, and I also wanted to take this, take a second to point out these titles that I've created. So each of these titles are actually their own cell, but they're a markdown cell instead of a code cell. So you can just make any cell a markdown cell, and then it's just, you know, I could put more text in here. So I could say, here we are averaging across character and face events. And then if you run this cell, it'll just show up as text. So that's nice just for annotating your code a little bit more cleanly. Okay, so let's go ahead and do the averaging. We're also gonna set an average reference for each average in this step. And let's take a look at these averages that we've created. So here's a butterfly plot for the average of the character events or segments. And we can click around on this plot to see different channels. So we see a few channels that are kind of sticking out that we might want to mark bad. So here, if we click here, we see this is channel 28, FP2. If we click here, we see this is channel 108. So that way we can figure out what these channels are, and then we can make a list of them. And like we did before, we can mark these channels bad. So again, we just set this info bads property to a list of the bad channels. And those bad channels will be saved in the output file when we output the averaged file at the end. Here's the other average. So same thing here. We've set a list of the bad channels for this one. And just a couple different ways we can plot the average data. So we can do a topo plot with the two averages plotted on top of each other. I'm going to zoom in here. So this plot is also interactive. There's a number of things you can do. So here we have the character average in blue and the face average in orange plotted on top of each other. We could zoom in even more, say we want to just look at this region, and we can drag this around. Yeah, so the interactive plots make it really nice for reviewing data. We can do topo maps as well. So these are nice for viewing the data at different time points on a colored scalp here. So here we plotted from minus 0.2 seconds from the stimulus. Here's where the stimulus happened, and then we go to 0.5 seconds after the stimulus, and then we can see the ERP really nicely here. Okay, so now we're ready to export the average data to MFF. So we'll go ahead and run this, and then when we ran the export function, that's just going to export to our Jupyter Notebooks workspace folder. So I'll show that in a second, but if we want to save the file back to the Flow database itself, all we need to do is run this participant.save and then give it the output path that we defined above. And this will save it back to the same participant that we read from. So let's run this. And then I'm going to save the notebook and log out. And if I go to workspace again, we can see our averaged file here. And then if we jump back to experiments and go to N170 workflow demo is our experiment. And then this participant, we can see our averaged file shows up here as well. Yeah, so I think I will pass it off to Justin now.
Hello, thank you, Evan. Hello, I'm Justin Nichols, sales manager. I'm in Dallas, Texas, and I'm going to show the fact that we can collaborate very easily with this data. And let me just share my screen here. Can everyone see my screen with Flow up?
Yes.
And so thank you, Evan. He just ran this file, this ERP sample 2 data. And so I want to see if I can access this and in real time. So I'm going to hit refresh up here. Click on this participant 2, and it is just popped up. So this data file he accessed. So it's great. You can be distributed. We all collaborate with multiple sites all over the place these days. And so it's great to have this kind of platform independent access to data in real time. And I think a lot of the best things that happen when you have this close collaboration, going back and forth, trying to tease apart what's in your data. So in this file, I can go in. He just ran through. He did this average within Jupyter Notebooks, and so just like Wei had access, just like Evan had access to this data, it's the same case here. So if I want to change view settings, etc., I can just kind of change timescales, change amplitude. You can see here character versus face. I won't go into details. We've done that, but same data, all within a simple Chrome browser. Very snappy, just over the network here. And so if I wanted to interact with this, or if I wanted to go into notebooks, I said, Evan, can you tell me about the filters that you implemented in this workbook? We can have our own Jupyter Notebooks within a workspace, but you can also have a share space here and have all of these scripts that are easily editable, changeable. Comments can be added in real time, and it's a great way to collaborate. And I think across multiple sites, typically you have different users with their own scripts and different expertise on filtering, different types of statistics, and people want to access that, implement it into their own scripts. And so it's a very easy way to go back and forth and not recreate the wheel every time you're trying to move forward in your analytics. But I will sign off here from Texas and hand it back to Wei.
All right, thank you, Justin and everyone. So one of the key objective goal that we designed Flow is to allow promoting the collaborative environment for the research world. Transparent, shareable, transparent, auditable, and reproducible is really what the researchers are looking for the software. So one of the notebook is actually a powerful platform for not just coding, but offers great documentation features. Let me share my screen here. So, if you look at, do some Google search, you would easily find out tons of information about Jupyter Notebooks. And as I was looking at these studies, there are some tips about using the Jupyter Notebook. Not only you can actually do the markdown and these features that allow people to actually see what you're doing, and also leave notes in the same code document for comments and feedbacks. You can also actually run the notebook. If you install a called RISE module, you can actually do a PowerPoint style presentation on a Jupyter Notebook. A great feature for really sharing with the research communities the work that you do. And also, you can save all the Jupyter Notebooks as the most commonly used text format, PDF, or even the HTML or the code py file, etc. For transferring and sharing. So we are continually working with also other commonly used data processing software such as MATLAB. Indeed, the Jupyter Notebook, indeed, let me actually open here. And I saw there's a question in the question area asking about MATLAB. Actually, Jupyter Notebook, MATLAB integration, there's a feature called MATLAB integration that can actually allow to open MATLAB desktop from the Jupyter Notebook through the web browser. So we are working on this. That means in the future, near future, soon, we will have ability to actually open a notebook, open the MATLAB from the notebooks. So here you see that in the new button here, you have a Python 3, which is the MNE, Python MNE is running on, but you will also see a MATLAB thread here in the near future. The conditions, you first need to have a MATLAB license. And then from there, you can directly launch MATLAB from the notebooks, launch the MATLAB desktop for data processing. And also we will provide features to write the output MATLAB data back into the Flow database, just like what we do with MNE Python. And we know that a lot of people are using the EEG lab, field trips, etc. And I think, you know, with that future open, it's gonna, you know, even broader the Flow's interoperability with the open source software. All right, thank you everyone. I think this is now it's the question Q&A session. So
yeah, I think you answered the MATLAB question that came into the chat. There are a couple other questions in here. One is internet connection necessary on a day-to-day basis to run Flow with an on-premise server?
Yes, you will need to have internet these days for your basic survival. So yes, you will need internet access for the Flow, in order for the Flow to run a Flow server to run, for you to access the Flow server. Yeah. So there are actually, if you talk about, so hold back a little bit, if you talk about internet as a broader term, you do need a network. For example, if you are living in a closed intranet, then you do not, if you're talking about you know, the inside intranet, and you can run within the intranet, you don't need not outside connect to the outside internet. But if you are talking about accessing the Flow server from outside, then you do need to have internet access. If that's what's the question about the term of the internet, a broader term or a more narrow term. A broader term is like everybody using the internet. The more narrow term is internet, is meaning the internet outside a closed network.
Right, so it might be different for people who are running in the AWS server as compared to an on-premise server.
Yes.
And we have two different options for people.
Yes. For AWS, then you can access from anywhere to the AWS service through the internet.
Okay. And then one other question we had about backing up data. A lab said they typically back up all data to our own lab server or portable hard drives. Are we able to upload this data to Flow?
And you want to answer that question?
Yeah, so it's possible to upload multiple files at once. So I think I showed briefly in my demo, dragging and dropping a file. It's also possible to highlight many files at once and kind of mass upload those files to Flow. So if there's a big collection of data on a external hard drive or just on a computer somewhere, the process for uploading that would be just creating experiments in Flow to organize all of that. But then, you know, if there's a large collection of files, it would just be a matter of highlighting all of them and dragging and dropping and mass uploading them to Flow that way.
Great. Well, if there are no other questions, I just want to thank everyone for coming today. And we will definitely have this webinar up on our website shortly with our other product webinars.
Thank you, everyone.
All right, thank you.
Thank you, Corey.
Thank you. Bye-bye.
Bye.